Hi everyone, this video is for section 9.1. Here we will be looking at a confidence interval for two population proportions. The question that we're going to be looking at reads, are more children diagnosed with autism spectrum disorder, ASD, in states that have larger urban areas over states that are mostly rural? In the state of Pennsylvania, a fairly urban state, there are 245 8-year-olds diagnosed with ASD out of 18,440 8-year-olds evaluated. In the state of Utah, a fairly rural state, there are 45 8-year-olds diagnosed with ASD out of 2,123 8-year-olds evaluated. We want to estimate the difference in proportion of children diagnosed with ASD between Pennsylvania and Utah, and we want to use a 98% confidence level. The first thing that we're going to do is state the random variables and the parameters in words. So, for example, one of our random variables will be P1 hat, and this will be the proportion of the 18,440 8-year-olds evaluated in Pennsylvania. Oops, slight misspelling. That were diagnosed with ASD. We're going to be able to use this structure as a template for our second random variable, P2 hat. Here we can say this is the proportion of the 2,123 8-year-olds evaluated in Utah that were diagnosed with ASD. Now we can move on to our parameters, so just P1 and just P2, so no hats. And what I would like you to do is go ahead and pause the video, use our random variable definitions as templates, and go ahead and create your parameters, your descriptions for those parameters. Once you're done, press play and we will review. So as we can see with the definitions for our parameters, notice that I've really only changed the sample size to the word all, because again, parameters are referring to populations. All right, let's move forward. Next, we're going to state and check the assumptions for the confidence interval. First are both simple random samples. If we go back to the narrative, unfortunately, it doesn't state if these were randomly sampled. However, I'm going to assume that these researchers were doing everything on the up and up, and that would mean that they were doing simple random samples when they were selecting children in Pennsylvania and Utah. So I'm going to go ahead and give this a check mark. Next, are the samples independent of each other? Really, we could argue that they are. Me sampling and selecting children from Pennsylvania isn't going to impact how I am sampling or selecting children from Utah. So I am going to say, yes, these two samples are independent of each other. Now, do both use the same two categories? Yes. The first category is the child is diagnosed with ASD. The second category is the child is not diagnosed with ASD. So kind of a complement kind of relationship. They're complements of each other. Bring them together and we have the entire collection. So I'm going to give this a check mark. Now we want to check for successes and failures. So again, depending on the textbook that you're working with, you're either going to be looking for 5 or more successes and 5 or more failures. In this case, I'm going to work with 10. Again, you have a formula that you could use, which is going to be the sample size times the sample proportion. But actually, our narrative gives us all the information that we need here. And to be a little bit more explicit, X1 and X2 are referring to those counts, those number of successes. So in this case, a success is defined as a child who was diagnosed with ASD. So for X1, those are referring to the number of children in our sample from Pennsylvania that were diagnosed with ASD. And that came out to 245. Likewise, X2 is referring to the number of children in Utah who were diagnosed with ASD, and that came out to 45. Both of these numbers are greater than or equal to 10, and they're also certainly greater than or equal to 5. So in either case, we've met the appropriate number of successes to proceed. But we also need to make sure that we have, in this case, 10 or more failures as well. So in other words, the number of children that have not been diagnosed with ASD. Moving on to our number of failures. So in other words, this would be the count of children within our sample who were not diagnosed with ASD. We can accomplish this with a simple subtraction. So I'm going to take my sample size, 18,440 from Pennsylvania, and remove the 245 children that were diagnosed with ASD. That leaves us with 18,195 children that were not diagnosed with ASD. And we'll repeat this process for Utah. In Utah, we had a sample size of 2,123, and we're going to remove those 45 quote-unquote successes of children who were diagnosed. And that's going to leave us with 2,078 children who were not diagnosed with ASD. So again, both of those numbers are greater than or equal to 10. That's the benchmark that I was using. Again, your textbook might be using 5. Either way, we can check it off the list. The last bullet point we really don't need to worry about. We don't know the full population size of 8-year-olds in Pennsylvania, and we don't know the full population size of 8-year-olds in Utah. We're going to go ahead and assume that this bullet point is met, and we're just going to move forward. Moving on to our third step, we're going to name the procedure used. So again, we're working with proportions, and specifically 2 proportions. So we are actually going to be conducting a 2 proportion Z interval. Next, we're going to find the sample statistics and the confidence interval, and we're going to use our TI-84 calculator in order to accomplish this. So what I want you to do is go ahead and pause the video and go through that process on your calculator. You hopefully have read through your textbook and have an idea of what that procedure is going to look like. When you are ready, press play and we will review those steps. Okay, so in order to carry out your calculator function in your TI-84, you would first press Stat and arrow over to the word Tests in the header menu. This is going to take you to a new screen where you will select option B, which reads 2prop_z_int, and press enter. That will take you to a new screen. From there, you're going to want to fill in each of the fields. Remember, X1 and X2 are referring to the number of successes, or in other words, the number of children that were diagnosed with ASD. X1 is referring to your Pennsylvania group. N1 is referring to your sample size. And then again, X2 is referring to your Utah group. N2 will be the sample size for that group. From there, you're also going to want to note your confidence level. And from the narrative, we note that we are going to be doing a 98% confidence level. When you press calculate, you'll get the following information in purple. So you have your confidence interval. You also get your sample statistics. So just to kind of call that out, your sample statistics are right here. So your sample proportions. And then again, N1 and N2, they're the same values that you had entered in on the previous screen. From here, we will want to state the conclusion. What I would like you to do is take some time and practice and build your own conclusion, making sure that you're including the level of confidence that you are working with, making sure that you are writing out the lower bound and upper bound of your confidence interval, and you are including context. So reference that narrative to make sure that you are painting a clear picture for your reader. The only other thing that I want to note before you all move forward is that our upper bound is actually working with a scientific notation. So when you were looking at -4e to the -4, this is really -4 times 10 to the -4. And if we wanted to convert that, for example, to its standard form, in this case its decimal form, We would locate that decimal value, or that decimal point, I should say, and then we're going to move this 4 spaces to the left. So negative 4 times 10 to the negative 4 is actually equal to negative 0.0004. All right. Again, go ahead and pause, take some time and practice this conclusion, and then go ahead and press play, and we will review. Okay, so we should have something along the lines of, we are 98% confident that the proportion of 8-year-old children diagnosed with ASD in Pennsylvania is between 0.04% and 1.54% lower than the proportion of 8-year-old children diagnosed with ASD in Utah. A couple notes. One, I chose to convert my decimals into percentages. It made a little bit more sense with regards to writing this conclusion for me as the writer, and I think it's going to be a little bit clearer for the reader as well. 2, I translated that negative symbol into the word lower. Remember, we're looking at the difference of these proportions, specifically P1, or the Pennsylvania group, minus P2, the Utah group. Since both my lower bound and my upper bound are negative values, this tells me that my proportion for P1 is smaller than the proportion for P2. So in other words, my proportion for Pennsylvania of their children being diagnosed with ASD is going to be a smaller value than the proportion of children that are being diagnosed with ASD in Utah. Because of that, notice I also switched the order of the numbers when I was describing this. Usually when we're describing these numerical values, we want the smaller value first, followed by the larger value. Because I'm removing that negative symbol and I'm just using the word lower, I have to switch the order of my upper and lower bound here in order for it to make sense. I really wouldn't say something like it's between 1.54% and 0.04%. That's kind of just bad grammar. So if you end up removing those symbols, so that negative symbol, we would want to go ahead and write it so that we have the smaller value first and then the larger value second. I hope that this was helpful. If you have any questions, please let me know.